Hello, Dr. Razi. How are you?
Hello, thank you very much for your time. I'm good.
I'm excited to talk to you. Let me introduce Dr. Razi. Dr. Razi is an Assistant Professor of Informatics, Computing, and Cyber System at Northern Arizona University. So he's an invited guest for our newsletter today.
Thank you for your introduction. Yes.
So let me go through our question. We have a burning questions. So number one, self-driving and safety system would be a shared initiative between AIMMO and you. And we would like to hear more about your research in this landscape.
Sure. Thank you for the opportunity. Basically, IAM is Institute of Automated Mobility. So this is an initiative that is supported by Arizona government, Arizona Commerce Authority, and several academic and industrial entities are involved in this project. So it is an effort between University of Arizona, Northern Arizona University, and Arizona State University, Exponent, Intel, State Farm Insurance, and many other role players. So the idea of this project is to develop a formal framework for assessing the safety of traffic, especially for self-driving cars, by processing video information that is captured by self-driving cars and also roadside infrastructure.
Excellent. So any challenges in this project?
Yeah, definitely. Like the research in this area has different dimensions and also different challenges. So one is the volume of data that we collect is huge. So we have hundreds of cameras on roadside infrastructure and thousands of like video feed from different vehicles, and then processing all these huge information and extracting meaningful safety metrics is computationally very challenging, both in terms of complexity and the amount of resources we need to process this huge amount of data, and also from computer science perspective, because there exists a lot of methods that address this problem from different perspectives. But when it comes to bringing all these components together and building a processing pipeline from A to Z, A being the video feed and Z being the ultimate safety regulations and safety guidance, is very complicated and multifaceted task. Basically, most of the existing methods are deep learning, and we have different teams focusing on different aspects of this problem. Integrating this is very important. So we have different sensor type of information, different video data modality from image, video, and different sensors, lidars, everything. And also different building blocks to process the information.
Wow, sounds like a very exciting project. So can you tell us a little bit about your other project?
Yes, sure, definitely. So another project maybe related to this one is aerial monitoring systems. So we have multiple projects in this area, developing communication protocol and also monitoring systems based on UAVs. As you know, like UAVs become very popular these days. They are not fancy anymore, so they are affordable and they come with a lot of features. Now then they have very good safety features, basically auto landing and self-navigation. So our focus in this project is to build network of UAVs and developing algorithms for optimal monitoring. So it includes research in different dimensions, like computation, how make optimal networking, and how to split tasks between network of drones when they work in harmony and in collaboration with one another. And our main focus is developing algorithms that are computationally feasible for drones to run on the fly with limited resources. Because as you know, like the big challenge for drones is their limited power. which also brings another constraints like limited communication range, limited computation power, and so on and so forth. So developing lightweight algorithms that can process collected imagery on the fly and basically taking decisions on time in a distributed fashion is the challenging problem. And in terms of applications, we are using this technology for a variant of applications. One is forest fire monitoring. So we have a collaboration with Forestry Administration in Arizona and School of Forestry and first responders to collect video from prescribed fire. We are fortunate to have a long-lasting collaboration with Forestry Administration. So we have prescribed and managed fire. It means that they ignite the fire by themselves. So it is under controlled environment, very unique to Arizona state, to our university. So we collect video from active fires, and the goal is trying to monitor the fire, how it behaves with different parameters, weather conditions, vegetation profile of the region, the topography of the region, and different factors. And then the drone's supposed to basically to model and predict how the fire is going to expand, and which helps the firefighters and other ground troops to basically invest their energy on areas that are more useful and basically more efficient.
Cool. And as an active research in unmanned aerial system and vehicle to everything, would you overview the technological landscape?
Yes, I think like a very good question. So there are many different basically research directions related to unmanned systems. To me, the biggest one is autonomy, because as you know, from practical point of view, still most of the drones are human controlled. You can have pre-path planning. It means that you can define mission, and then most of commercial drones, they follow the mission using like waypoint and other models. But the thing is that when things happen on the fly, which is unexpected, to react basically appropriately to these situations is a big challenge. So making drones smarter and smarter as real live basically entities is the big challenge. And like there are some attempts and research trying to make self-learning algorithms for drones. But the challenge is like I said, the computation power. Like some people try to use GPUs or lightweight FPGA-based processing units for GPAs, which are constrained actually based on the power and so on and so forth. So autonomy is number one. Number two is networking. Most of the like existing networks are basically few drones, but the tendency is to go to miniaturized, very small size of many number of drones. And when it comes to drones, how they can balance basically and split the task among themselves, and how coordinate this big network of drones, like an orchestrate this huge network, and implementing distributed computation and learning algorithms for drones is, to me, one of the important future challenges.
Oh, wow. Thank you for sharing your insight. I feel like our newsletter audience will be very informed of your active research, and I really appreciate your time.
Thank you very much.